Alrighty, so like I said yesterday, or Monday, we're gonna be switching a little bit of the order of what we're doing. So I went ahead and went through the notes for part of 7.3 that was talking about slope, and whether or not something was a parallelogram or not. Today, I'm gonna be talking about some more easier concepts since I'm gone. And it's just, again, your properties of parallelograms. So you should have out your parallelogram sheet. I'll open mine just so that we have it open as well. Okay, and then I can refer back and forth to it, or we'll just keep it here because this is all we need. Okay, so in 7.3, our warm-up here is talking about the properties of a parallelogram, just marking them up. So I'd encourage you to maybe go ahead and add in the markings that we've talked about. One of them being like, hey, opposite sides are congruent. So it's good to get in the habit of recognizing these things. Opposite angles are congruent, okay? If you want, you can go ahead and draw your bisectors in, or your diagonals in, and draw on the bisecting piece. This is just for you to have a picture with kind of everything that we've talked about with parallelograms on it. So using our sheet here that we talked about, maybe putting all of this at the top on one picture would be kind of nice to do. So if you want to pause and take a second to continue adding in some things, go ahead and do that. So what we're going to do today is actually pretty easy because it's basically stuff we've been doing. We're just talking about, it's basically reversing the quadrilateral properties we already talked about. So like on slide 36, it says if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. That is the second thing we talked about. It's again just kind of reversing what we've already talked about in 7.2. So I'm not going to add anything additional to slide 36. Same with slides 37. Again, this is just talking about the properties of a parallelogram. We already talked about these a lot last week, so I'm just going to kind of bypass through these and get to the examples for our video so it's not super long. In this part, it says, Jude says that by theorem 7.12, you only need to show that one pair of opposite sides is congruent to show the quadrilateral is a parallelogram. Do you agree? So 7.12 is this theorem right here, okay? It says if one pair of opposite sides of a quadrilateral are both parallel and congruent. So in slide 38, it says, is it okay if it's just congruent? No, one side has to be both parallel and congruent. I'm going to go ahead and sketch a little picture with that as well, because they also, this was something we actually saw on our classifying sheet, and some of us did not get it correct because it's a little tricky. So we have to have one set of opposite sides being both parallel and congruent at the same time. So our picture would look like this for theorem 7.12. Okay, so that again was on that classifying worksheet that we did at the very beginning of this module, but I just wanted to like put that into perspective that this is what we're looking at when we talk about theorem 7.12. Okay, looking at slide 39, it says determine whether the quadrilateral is a parallelogram. Justify your answers. So if I look here, these two sides are congruent. These two sides are congruent. So yes, this would be a parallelogram. And the reason they are is because opposite sides are congruent. Okay, again, that's something we've already talked about, something you should hopefully already know. Now we're going to work with some algebra. Okay, so now we're going to actually set up some equations, solve for some pieces of just like some more application problems. So on slide 40, it says the top of the eraser appears to be a parallelogram. Find the values of x and y so that the side of the eraser is a parallelogram. So we know that opposite angles are congruent. So where this 56 is, that's congruent to where the 7x is. where that 5y minus 26 is where the 4y plus 4 is. We need to set up two separate equations. And again, we talked about this last week, but remember, when something is congruent, we set them equal. Okay, so congruent always means setting equal in an equation. So I'm going to look at the x's first. So I've got 56 and 7x. It doesn't matter what order you write them in. I'm going to write the x term first, just because then x is on that left side. So it'd be 7x equals 56. Divide by 7 on both sides, and we get x to be 8. So that's a really simple one of solving for x. The other one's going to take a little more work. So if I have 5y minus 26, those are congruent to 4y plus 4. So we'll set them equal and then solve for y. I'll go ahead and subtract the 4y from both sides. So I get 1y minus 26 equals 4. Add the 26 over. I get 1y equals 30. So y equals 30. Don't need to divide there because it's just a 1 as the coefficient. You need to be very diligent and good about solving these equations, okay? That's why I'm not taking a ton of time to do those. All right, go ahead and flip over to the next page. Now we're looking at a little pattern made by some tiles. Again, we're going to look at our problem, set it up, get it solved for. So the first part says find the values of x so that the tile is a parallelogram. These are around the outsides, so these are referring to the sides. So the left side and the right side is parallel or congruent, and the top and the bottom are congruent if we want it to be a parallelogram. So again, this part, it's just asking for x on this slide. It's going to ask for y on the other side. So on this slide, we're just looking at the x's, so the 3x and the 5x sides. Since they're congruent, we're going to set them equal to each other. Okay. You can solve it however you would like. I'm just going to quickly solve by subtracting 5x from both sides and then subtracting 4 from both sides. Then dividing by -2. And we get x to be 3. On the next slide, it's asking you to use the same picture, but now we're solving for y. Those sides are still going to be congruent because we're still wanting it to be a parallelogram. So I'm looking at the top and the bottom. Again, we'll set them equal to each other. I want you to go ahead and try and solve this problem. You should get y to be 7 when you're all the way done. But I want you to actually solve this out, okay? If you're not doing that, you're not getting the practice that you need for this lesson. Slide 43 is just asking why we set up our problems the way we did. We were looking at the sides. So obviously, like letter B wouldn't work, right? That's talking about angles. Letter C is talking about diagonals. That doesn't work. The two that talk about sides are the A and D. A says if both pairs of opposite sides are congruent, then it's a quadrilateral. That is the statement that answers why we set up how to solve for x and how to solve for y.